keynote speaker for tonight, Dasvinder Kambo, who is one of the co-organizers of this event. Das is a second-year PhD student at Queen's University who focuses his research on alpine tree lines. Before coming to Queen's, he did his undergraduate degree, graduating with high distinction and master's degree at the University of Toronto, specializing in ecology and evolution. Since his undergrad, Das has been involved with many research projects, 5 to date, which is rather impressive. As a double recipient of the NSERC USRA, Das's early research focused on terrestrial planet invasions throughout central and northern Ontario. In his short academic career, approximately 7 years since he started his undergrad, Das has been rewarded over 20 academic awards, including most recently the NSERC Graduate Scholarship. That's a lot of awards. I'm impressed. Okay, so what makes Das stand out from his colleagues is that he's involved with so much. While completing his degrees, Das worked as an advanced medical first responder with St. John Ambulance, worked with the campus police, and worked with the campus response team. In fact, during Das's final year at the University of Toronto, he orchestrated corporate funding to install automated external defibrillators in every building on campus and subsequently trained everyone on how to use them. During the 2 months between his master and PhD, Das traveled to Africa and helped local villages with farming and agriculture. Over his short career, he has been given over 14 awards for community involvement. In addition to community service, Das is also very passionate about science. He's been published in high-ranking journals, led science seminars for the Ministry of Natural Resources and various First Nations groups, guest lectured numerous times, and has presented over 10 scientific conferences in the past 3 years. It's my pleasure to introduce our 4th keynote speaker, Dasvinder Kambo, and his talk titled Science and the Media, Don't Believe Everything You Read.
It is really weird to have someone read out everything. You don't think, thank you. It was really awesome to have it all listed out like that, and I suppose a little bit humbling also, but mostly thank you all for the really warm welcome. So I changed a lot. So I've done this talk a couple of times, and I've changed quite a bit of it for today, for purposes of today. So today's seminar is going to be focusing on the interaction between science and the media. We will explore differences on how information is gathered, how information is explored, and pretty much how information is portrayed. Now, this seminar is going to be a little bit different than the previous or the other 4. This one's going to be less about climate change per se and more about how publications are formed and how media publishes and how bloggers publish and how we publish. But we are going to be using case studies in climate change. So in the first part, we're going to be exploring the word publication. In the second part, we're going to work to see how you get published. And then the third part, we're going to be looking at climate change as an example to see how information can become distorted. So the first step to any academic pursuit is figuring out definitions. So how do we define words? And more specifically, does the definition of publication hold across all domains? I'm going to let you guys in on a little secret. They're different. Everything uses a different everyone uses a different definition. As a researcher, we are often based, so the measuring stick of any good academic is based on the number of publications and the impact factor of our publications. News corporations keep track of the amount of people that visit their websites, because they can use this information to tell the advertisers, hey, look, we had about 13 million visitors a day. Give us more money for advertising space. Worded a little bit less directly, of course. For news media on television, we use what's called a Nielsen index. And with a Nielsen index, you can actually pinpoint the number of people that watch a show at a specific time. So all these things are influencing pretty much the number of publications. Now, I published a blog for this specific seminar series. And in that time, over 2,000 people have visited the page, which is actually fantastic, by the way. So technically, 2,000 people have viewed my publication. Now, I'm not willing to write that on a resume that I published a blog, but it is something that one can consider. But all these definitions of publication, it ultimately comes from a combined legal definition, which literally means to communicate to a third party. And you can see by using that definition how almost everything that we do for the public can technically be classified as a publication. So I'm a literal person. I do things based off flowcharts, graphs, tables. I'm a science man. So every time I have to come across with a new definition or a new term, I always draw flowcharts. It's how my mind works. So here we go. Publications, right? And right off the bat, we can split these up into two types of publications. You have your user-defined publications and your prose-type publications. Now, with user-defined are things such as video blogs or flyers, things that you can just spew out, and that's pretty much the end of it. For prose type, it often requires an editor or a publisher. So there is some vetting of the information. There is someone there to proofread everything that you're doing. Now, prose type, we immediately split this, and everyone who's gone through grade school knows that we can split this up into two sections: fiction and nonfiction, or as I called it when I was younger, fission and non-fission. Unfortunately, I was way too old when I realized that I was actually saying it wrong. But anyways, fiction itself can be further split. Well, both of these can. So when we split fiction, as we know, is defined as imaginary-ish type of events, things that aren't per se real. And we can split them up into realistic, semi-fiction, science fiction, and things that are just not realistic at all. Things that could be real is with Sherlock Holmes. Now, Mr. Sherlock Holmes over here, this is not something that is real, but it could be real. It is within the realm of realism. So we call this realistic fiction. You have semi-fiction, things that are based on true stories. But to make the story more entertaining, we've now distorted some of the facts, such as 42, the Jackie Robinson movie, which I just saw, and Harrison Ford is just fantastic. And then there's science fiction. Now, science fiction, I like science fiction, but science fiction itself is based off of this endeavor of future technologies. We might one day get there. Things like Star Trek, Star Wars, and pretty much those are the only two that you really need to know. And then there are things that are non-realistic at all. And despite my absolute heartache to say this, things like Lord of the Rings and Harry Potter will never be true. My niece is not going to see this presentation until much, much later. She still thinks that if she eats enough vegetables, she can become an elf. I haven't corrected her. But what we're here for is things in the fiction side. In the non-fiction side, rather. And these are based off of facts. They're based off of events. They're based off of people. And these are things that we can kind of start putting numbers on, right? And you can have things that are editor-based and things that must be peer-reviewed. So things that are editor-based can be peer-reviewed, but they're generally not. Actually, in most cases, they're not. So these are things like media, essays, documentaries, biographies, photographs, travel guides, things that need to be edited, need to be proofread, but there's no peer review process in place. And then our shameless plugs over here, we have science on the other side, which everything needs to be peer reviewed. So you have scientific papers, review papers, various types of research publications, and textbooks. Ultimately, things on the peer review side take a lot longer to get published. Now, I'm going to be focusing on three types over here. So we have vlogs and blogs, which we're going to shoot through really quickly. We're going to focus on media, and more importantly, we're going to focus on the interplay between media and our scientific publications. So we start off with blogs and vlogs. Now, there are hundreds and thousands of types of these. Facebook, Twitter, my blog, MySpace, your space, everyone's space. Every single day, new blog sites come out. And it seems that these sites all kind of do something different, but ultimately it's the exact same plug. You publish very quickly. It's very easy to publish via these mediums, especially because outside of you saying something that's illegal or outside of the law, no one really cares what you write. So that's an interface that we're going to be going through really quickly. Now, I wanted to show you guys how easy and how fast it is to publish via a blog. So it took me less than 60 seconds to do the following. Before we go into that, these are various examples of blogs. So we have blog.com, we have Tumblr, we have type pad, all things that are functioning within making information as quickly as accessible as possible. Now, a lot of you guys have been to this website, and this is the website that I've created for this particular seminar series. It's through WordPress, which is another type of blog. Now, I wanted to see how fast can I publish something? Well, quite easily, because conveniently right over here, if you want to do a new post, you just click on the button that says New Post. So I clicked on it. I landed on this page. I wanted a text, so I clicked on that. Another page popped up. What would you like to type? And you guys have been so fantastic that I wrote a little thank you letter, but I'm a little bit embarrassed to read it right now, so if you guys can all read it at your own time, that'd be awesome. So I decided to write you guys a little thank you note, and then I said, let's publish this. And voila, we've been published. That quick. If anyone wants to get published, I recommend using blogs. You can tell your supervisor, hey, I've been published like 50 times in the last year, and it won't actually be alive. We're done. And this is what it looks like online. So it's there. Now, that's blogs. That's very easy. Now, the next type of publications that I want to kind of venture into are media publications. Now, if you remember, media publications do have editors. The work is vetted by someone else. In this particular section, we're going to start looking at different types of media publications. So it's kind of funny. Publications started many years ago where images were transcribed onto wood or stone, and by making it available for other people to see, these stones or blocks were technically classified as publications, just like the blog example that we showed. But when we think of publications in recent history, we think of things like newspapers or radio, or this handsome fellow over here that's reading the news for us. Funnily enough, actually, a little bit of an anecdote. I was talking to my mom about this presentation that I was going to be doing about media publications. And I asked Mom, Mom, what do you think a media publication is? And she responded, without hesitating, television. I'm like, okay. I asked Grandma the same question, by the way, and Grandma said newspapers and radio. And my mom, without flinching an eyelash, or I don't know whatever the expression is, she's like, Grandma's old. Of course she's going to say the newspaper. And I'm like, okay, easy, Tiger. Just letting you know, Mom, that almost all information now is online. In fact, recent polls suggest that almost all news media is now done Facebook, Twitter, or specific websites that they've created. So if you're going to go with those numbers, Mom, then I think a television is a little old too. She doesn't want to hear that. No, actually, I suppose no one wants to hear that. But it's true, though, if you think about it, because media publications are evolving. Updates are now received online, on the television, and all these forms of media, it doesn't matter because it's all considered publications still. So, and there are thousands of these companies that are out there. Now, I don't want to get into conversations about net neutrality or conglomerates or the function of the CRTC. That's not really what I want to do. But what I wanted to emphasize here that various media companies do exist. Now, I wanted to get a feel for the audience right now. These are 6 companies, the top 6 companies in Canada right now. In terms of media publications and revenues, what's the market share that you think that these 6 companies own? So, by raise of hands, who thinks more than 50%? All right, there are a lot of cynical people here. All right, more than 60%. Okay, we're going places. More than 70%? More than 80? More than 90? Okay. The estimates are actually placed between 80 and 90% is owned by these 6 companies. I want you guys to consider that because we're going to be coming back to this information in a few slides from now. Now, we know that there are 6 major companies now. So we know that there are 6 big media corporations. How does one get published with them? Now, media publications can fall into one of 3 categories. You either have paid journalism, you have freelance journalism, or you have submissions. So with paid journalists, you are full or part-time employees that kind of commit themselves to longer-term stories, or higher caliber stories, if you will. And And they're generally focused behind some kind of a portfolio. So you can have health specialists, sports specialists, political correspondents, foreign correspondents, etc. And two such people are Karen Humphreys, who's a sports person, and, well, Peter Manbridge, he needs no introduction. And then you have freelance journalists. Now, it's a little bit weird here because they can either be sent on assignment or they can come across a story, write up a story, and submit it to an editor. So they can go one of two ways. So for example, what's happening right now in Ukraine and Crimea and Russia, editors of newspapers might actually send freelance journalists there, get the information, and send it back to us. Or if someone already happens to be there, they can just be writing the stories and submitting it to an editor. Either way, they're freelance. And then we have submissions. And generally, this is done via letters to the editor. There's entire sections of newspapers that are devoted to this. Regardless of which method you use, everything goes to an editor. And it's the editor that chooses whether or not to publish this. This decision rests with him or her alone. Now, I want to emphasize that, but I also want to emphasize another thing, the time frame over here at the bottom of the slide. We can go from stories to publication sometimes as quick as a few moments. And you have that with breaking news. So when something happens that a couple of minutes ago, you can have someone that's on the ground writing the story, email it to the editor, and the editor can publish it on a website somewhere, or Twitter or Facebook, or even send it out to mobile phones for some certain subscribers in a span of minutes. Now, most stories are generally in the form of hours to days, but rarely are they longer than that. Now, knowing a lot about media publications, let's jump a third time to scientific publications, because they're very different, and we're going to get to that right now. Now, this is a cartoon that I use for a lot of my first year classes. I actually love this cartoon quite a bit because it simplifies a pretty complicated process. So over here you have scientists with conveniently white lab coats. I don't wear a lab coat because I am, what Leah said, a hippie. But most people do actually wear lab coats still. They make an observation, in this case by looking into a telescope. And scientists study something, they write about the results, they process the data, they send it to an editor. The editor at this point looks at it and says, this is horrible. Why are you wasting my time? And can send it right back. Or the editor can look at this and say, this is pretty good. Let's send it to other people. Let's vet this information. So then the editor sends it to a bunch of peer reviewers. These reviewers read the work. And then, based off of what they say, they can either tell the editor, this is pretty bad, don't accept it, or, this is pretty good. Following some modifications, let's publish this. Right? So these are the way it can work. But this entire process is a little bit more convoluted than this. So I kind of wanted to go through this with a little bit more detail. And they require a lot more time to publish. So for simplicity's sake, because I learned with case studies, I decided to use my master's work that I published only a couple of months ago as a case study. So in our case, we're going to go from each step. We're going to go from actually the observations in experimental design all the way to the very end of actually getting the work published. And we're going to see exactly how long it takes to go through all of this. Now, this is pretty much the final product. This is what it looks like. It was published in Biological Invasions, but you don't know that yet. We're going to find that out on the last slide. All right, so observations. So the step one of a scientific publication requires observation. And this always leads to some kind of experimental design or hypothesis. Now, my master's project, using that as a case study, my supervisor, Peter, he noticed over many decades of studying natural ecosystems that non-native plant species, so pretty much plants that are not supposed to be in North America, these are plants that were originally from Europe or from somewhere else and they've come to North America, their range increases very quickly. And what else he noticed was that in addition to this range increasing really quickly, plants on the outside of the range grew differently than plants in the middle of this range. So he had that observation, and he decided to hire me as a master's student to go out and figure this stuff out. So I did. I designed an experiment, and I had a hypothesis, and I had my sample organism, or my focal organism, which is Arctiomyces or burdock. Now, everyone knows what burdock is. It's the thing that sticks onto your clothes or onto your dog when you go for walks in parks. It's horrible. I defined it to my undergrads as herpes of the plant world. And they suddenly kicked in really quickly. I don't know why, but moving forward. So the second step of all this is to actually collect data. So I went across to 12 different sites across Ontario, ranging from Newmarket over here all the way to 850 kilometers north to Moosonee. At each location, I collected a lot of plants. So I had about 600 plant samples across 12 locations, and I had 2 sampling periods, in the summer of 2010 and in the summer of 2011. The next step, after collecting all of this, is to process and analyze the data. Now, I didn't want to show you guys all my data because, well, just take my word for it, there's a lot of it. It's pretty much 15 Excel spreadsheets. Combined, it has about 19,000 rows of data, about 225 columns of data. It's summarized in 50 graphs and 10 tables. I could show you guys all those graphs and all those tables, but there's just lots of data. Let's just call it at that. But ultimately, after analyzing all this data, I actually had to write the thesis and defend the thesis. Now, that involves me sitting in a very dark room for about 6 months on my computer, drinking an unhealthy amount of caffeine to publish this, or rather to get this to defend the thesis. And this is something that I wanted to show because Queen's actually does this too. Now, this thesis is actually on the U of T servers, but Queen's does this also. In order to make information a little bit more accessible, there are online copies of theses that are available to the public. You just go to the Queen's Library website, go under theses, and start selecting the name or the type of research that you're looking for. So in essence, this is what it was after I defended the master's project. Now, that's not over yet, though. After you defend, there's another step. And I absolutely love this comic, by the way. PhD comics is what all PhD students actually live by. It's absolutely hilarious. So in essence, I started off really happy, like I just finished my undergrad, I'm going to go to grad school, and I'm going to be really happy. I was even happier than this fellow over here, except my gown was black, not blue. Anyways, I'm now in the lab, we're collecting data. Things are a little hard. Equipment's not working all the time. There's a lot of people who want to use the equipment, but, still on the up and up. And then you realize your data doesn't fit any known statistical model. And you're starting to cry. You have no idea what's happening, and you're drinking a lot of coffee. And then after you finish your thesis, you're completely at the mercy of your supervisor. And it's your supervisor that determines whether or not this is going to go forward or not. Now, we're all joking over here, but the reality is not actually far from this. But publications are different than theses. With a thesis, my thesis, for example, was 165 pages. The average publication's about 10 pages. So we have to shorten a lot of that information down before publishing it. So you can see how we're supposed to cut out a lot of material. Now, research publications there are thousands of journals that you can publish in. And ultimately, people pick these journals based off of target areas. What we mean by target areas, you obviously don't want to publish a genetics paper in geology, or you don't want to publish a phylogenetics paper in an economics article journal. You don't want to do stuff like that. So there's target areas. And within each target area, there are different journals that one can use. And researchers pick the journals on trying to maximize the prestige. In the prestige, we classify it as impact factor. So researchers are always trying to publish in the highest ranking journal based off of impact factor as possible. Now, what I really want to emphasize the point over here, impact factors may be directed at more red science, but it doesn't mean it's better science or worse science. It just means that it's more interesting science, but definitely not better or worse. I say that because I'm obviously published in not a lot of high-impact journals. And then the next step, you submit submission. Now, after rewriting this for a few months, I submitted this to a journal, as we know over here, Biological Invasions, and I want you guys to see that we submitted this on December of 2012. I started collecting my data in 2010. We're going to get to the time frame, or keep that in mind. Then the next step is rejection. I always put rejection as a step over here because some journal, the rejection rate is higher than 99%. So in April of 2013, I found out that I was just part of the other 99% rejected. And we had over 40 recommendations that needed to be addressed in our published work. Now, most of these were simple grammatical mistake, entering a comma here, putting a new paragraph, changing a reference or two, but some of them did require reanalysis of the data, which is not fun. So you resubmit. And upon resubmission, which was done in May of 2013, this was accepted by the journal in June 2013, and it wasn't published until just a few months ago, January of this year. You can see it's right over there. Now, remember this slide? Everything goes to the editor makes a decision, and oh, the beautiful time frame, minutes to hours, days, rarely longer. Well, this is what it's like actually in academia. It's a little bit different. The choice rests with a lot of people. So there's one of two things that I want to kind of point forth over here. One is your data collection. It takes a long time to collect data. It's not just you go outside, you're like, that's a tree, let's just measure the height and call it a day. I wish things were that simple. A lot of my colleagues actually have to look underneath microscopes and look for diatom species. So remember what John Small talked about? They have to individually count species of diatoms. John Small's not going to do that. There are grad students for that. Please don't tell him I said that. So data collection takes a long time. And upon data collection, we have to write the thesis, which there's only so much caffeine in the world. Then you have to defend your thesis. Then you have to write it up for publication, so you have to change the way you write it. Then you get some department reviewers to look at it. Then you submit it to an editor, who then submit it to external reviewers. Then the external reviewers come back and send it back to the editor, and then it's published. Time frame. We're not talking minutes to hours over here. It took 1,280 days from the start of my project to get it published, or 3.5 years. Yeah. Now the second point that I want to make, I know everyone's absolutely stunned. I was too. Now the second point that I want to make is the vetting of the information. Now this is the important part, because this is the peer review part. So obviously, writing up the master's thesis, I obviously have a huge say in how it goes. So it's my decision whether I think this piece of work is good enough to submit to my supervisor. And before you guys ask, the answer is always no. It's never good enough for your supervisor. So you write something up, you submit it to your supervisor, and then your supervisor, who will do this 99 times out of 100, tell you it's not good enough. So then it goes back to the drawing board. So you rewrite this, and eventually your supervisor, begrudgingly because deadlines are looming, finally says yes. So after that, you have everyone that helped you out with the data has an opportunity to read the project too. So in my situation, I had 4 research assistants helping me out with this project. So every one of them had to read the paper, and every one of them had to read the master's thesis, and every one of them had one opportunity to say no or yes. So after I've convinced all of them with caffeine and ice cream, we go on to the committee. There's no bribing. I was joking about the ice cream and coffee. Actually, not so much the coffee. But then it goes on to the committee, and this is the defense that we're talking about. So you have 4 additional committee members, all faculty members, and you pretty much stand up in a room and they're constantly telling you what you're doing wrong, and you have to defend your research. After that, you write up the manuscript, and then you send it forward to 2 departmental reviewers, who then look at it, and they can say yes or no. After that, you submit it to an editor, who can say yes or no, and then after that, it's 2 external reviewers, sometimes 3, who say yes or no. After that, if it gets published, it has been reviewed by 15 experts in this case. 15 different people have looked at my research and said, all right, it's good enough to get published. This is what we mean by peer review. It's a very long and arduous process, but it's been looked at by by many people. And now at this point, we looked at the different types of publications. I kind of want to take a step back right now. Because at this point, we're now going to start talking about how publications in science differ from media. So the next section talks more about how they come together. So briefly, going back to the media publications, the target audience, you guys, the general public. They want to target you guys. For research, when researchers publish something, we really only target other researchers. I don't expect everyone to understand, really minute parts of my research other than other people who study an equally minute part of their research so we can compare minute parts of a minute research project. That's only half joking. And then funding sources. That's something else that's really important because the media, they get their funding sources from subscription fees, from advertising. And I say donations very loosely, and we're going to get to that. Our research, we get funded through various grants and bursaries and scholarships, but ultimately this money comes from, once again, you guys, taxpayers. So thank you. So we take your money, and we also get money from other people who generously donate to the university. And we get a lot of food from our parents, so I decided to give them a little shout out too because, well, I gotta eat. So they're pretty different, right? They're pretty separated. But we know intuitively that they're not very different. And they're not different. There's a lot of interaction between the two. There's a lot of interaction between science and between the media. And that's what we're going to be focusing the rest of this presentation on, or the rest of the seminar on. And this stems because the public wants to know. The public wants to know what science is happening, what we're doing in the research world. So based off of this, things such as Jay Ingram's program, The Daily Planet, has popped up. The Discovery Channel. You have The Nature of Things with David Suzuki, which is purely Canadian. Over here we have the Climate Reality Project. Groups form around science. And then a lot of this really kind of came to a head in Al Gore's movie, The Inconvenient Truth, which anyone who's remotely interested in environmental studies has taken a look at. So the public wants to know what researchers are doing. That's one part of this. The second part of the equation is that scientists want public to know what's going on. Some researchers are doing some pretty cool things, and they think the public would know. Look over here, see what we're doing, kind of a thing. So over here, you have a C-section performed on a turtle. If I did that, I would want people to know. That is resume material right there. Over here, there's some scientists that claim that they can clone the woolly mammoth. That is also something that I would want people to know. Ideally, it would be done by two different people. And then over here, there are another set of researchers that are able to convert plastic bags into efficient diesel fuel. These are things that researchers are doing, and we want the public to know. So this has allowed a niche to form in the media. Scientists want the public to know, and just as strong, the public wants to know what's happening in the scientific world. But alas, there's a problem. Stated simply, scientists aren't good communicators. Scientists are trained to think and act in a very certain way, and unfortunately that way is different from the way the public perceives information. Thus, we need science communication. We have science media. Media via journalists take scientific information and explanation from researchers, and they explain it in general terms so that everyone could understand. So there becomes a sense of mutual reliance. Scientists need the media, the public needs the media, so we're all kind of forming some kind of a marriage. And unfortunately, there are problems because sometimes the science becomes oversimplified. And sometimes too many metaphors and analogies are used that don't really make anything much easier. But there are other flaws, and we're going to discuss them. So, why isn't it a happy marriage? Why are scientists always complaining that the media are doing things wrong? Why is there a disagreement? Why is there a discrepancy? Why are things not happening together properly? Well, the discrepancy is due to many factors, but ultimately it comes down to ownership. Stated another way, it all comes down to how this influences you guys, the public. So, put you guys right in the middle of the slide, the public. Now, you guys pay taxes. It funds science. Thank you, by the way. seriously, thank you guys. So we get our science, we publish the science, and we come to a conclusion. For the sake of simplicity, we're going to call that conclusion Y. Then conclusion Y goes into changing societal norms. We use those changes in societal norms to go back to the public, who then once again pay more taxes, and the whole process keeps continuing until we get to some kind of utopian world. It's probably not going to happen. But anyways, now we have the public over here with the media. And the public pays the media either via subscription fees or by merely just watching that media, so that media is capable of getting advertising funds. So they come to a conclusion X. I just had to make sure it was different from Y. And this conclusion is used once again by the by the public. So over here now we have this cycle that forms, not unlike the cycle we had before. But the difference is, remember those 6 companies that we talked about before? Well, they own the media. And that's something that we need to consider, because ultimately they're going to own the media. They're going to want a conclusion that influences the public that indirectly helps out the 6 media companies. So they want a little bit of that conclusion to go their way. And I don't want to engage in conspiracy theories, but ultimately, if you own something, you want something to come from it. So in this case, the 6 companies that own the media, they want something to come out of that media. It's a little bit different than this. This is just one circle. Over here, now we have 2 circles. We're going to start taking a look at that, because a lot of this and a lot of this comes from differences in funding. So let's take a look at that. Now, funding's important. The thought of disagreement has been created by a relatively small group of people. Now, this quote was made famous in the Inconvenient Truth documentary that I talked about. Now, in order to kind of remain as neutral as I possibly can in this seminar, I decided to get rid of the name of the people who actually made this quote. But it was in the coal industry, from one business executive to another. And they wanted to reposition global warming as theory rather than fact. This was information that was leaked to the media. Suzanne Goldenberg from The Guardian, between 2002 and 2010, as you can see from this graph, over $120 million was given to climate change denying groups. So that's this graph over here. So we're starting off with 2002, go all the way to 2010, and these are the millions of dollars that are being pushed to climate change denying groups. If I had $120 million, our lab would function really differently. I would have so many research assistants, probably 120 million of them, and actually no, then I'd have to pay everyone $1. The right amount of them. But in essence, most of this money comes from private donors. And that's where it becomes interesting, because you can't tell people how to spend their private money. That's their right. So we start to run into a little bit of a problem. The Koch foundations, that's pretty much oil and gas. And then ExxonMobil, that's also oil and gas. So I'm cherry picking on the media. I know I'm cherry picking on the media. But the divisions are not always media-based. Divisions are not always media telling science and science going with media. Sometimes these divisions occur differently. And we're going to talk about that. Now, this is where it gets really interesting, because polls are a very good way of gauging what the public thinks. Polls are not scientific, but they do show opinion, and that is important. So this is American poll. I'm going to show Canadian polls on the next slide. So via the American polls, 84% of Democrats think that the Earth is warming. 46% of Republicans think the Earth is warming. The people who did respond yes to this, 64% of the Democrats think that humans are responsible for this Earth warming, whereas 23% of Republicans. The last question is a little bit more pertinent, it's a little bit more useful for me. So this last question talks about scientific consensus. So they asked the US public, what do you think the scientific consensus is? And they think that 54% of it, the scientists agree, and 37% think that scientists disagree. this is one of the more important numbers, because this tells us what the public is thinking in the States. Now, things are fortunately a little bit better in Canada. Our poll results show that 81% of Canadians think that climate change is happening and climate is warming, but 58% of it think it's anthropogenic, and 15% think it's due to natural patterns. The other people think it has something to do with both. Now, ultimately, these polls suggest one thing, but one of the key things that I figured out from these poll results is that more conservatives think that it's natural climate change, and more liberals think it's anthropogenic climate change. So this adds a component to everything, because it's no longer science and morals on one side. It's no longer what is scientifically valid or what is morally right. This now starts to become a conservative versus a liberal agenda. This starts to become a Republican versus Democrat agenda. This starts to change what the science is actually telling us. And add to the fact that funding is different. So where do the media company get their funding? It's from the owners. Now, the owners obviously own the media companies, and they also have right and left-wing tendencies. So some media are more right-wing, some media are more left-wing. Now, the most obvious example is Fox News, and I couldn't help myself. I combed through YouTube to find the perfect Fox News, and let's see if the volume works over here. Let's see.
President Obama in drought-ridden California Friday proposing a $1 billion fund to research and help communities deal with the effects of climate change. The president's case may seem a bit hard to make when the eastern half of the country is in the grips of a brutal winter, but as you heard the president say, climate change accounts for everything from drought to floods. George, do you buy it?
No, I'm not into science, but I'm one of those who are called deniers. When a politician, on a subject implicating science, hard science, economic science, social science, says the debate is over, you may be sure of two things. The debate is raging and he's losing it.
Climate change, I think it's fair to say, used to be a very hot topic, no pun intended. In fact, it used to be called global warming. Now, not so much.
If we had a better economy, I think people would have more of a luxury to worry about climate change.
And maybe you know, because I don't. When did global warming become climate change? When?
It became climate change when you couldn't prove that there was much global warming anymore, as the temperature didn't change. So suddenly we had to have this catch-all term that was responsible, it meant that any change in the weather somehow supported the theory.
Now, let's just say I decided that I have the best publication, and I publish in a very high-impact journal, Science or Nature, and I have the best data that says climate change is happening and it's anthropogenic. Who's going to read a science article? You're going to have to pay for subscription fees. You're going to have to pay for this. This comes free to your television. If you have very limited sources of information, this is it. In fact, a lot of people in the States and a lot of people in Canada have access to very few news agencies. So they have nothing else to depend on for their news except for the wonderful people at Fox News. So this is something that we need to consider. Now, I've gone on and I scoured the interwebs, and I wanted to look for more of this stuff. And I put on my favorites. Now, here we have a caricature in the background over here that says 12 out of 13 scientists agree that global warming is a hoax. I would very much love to meet the 12 people. I would like to just see who these 12 people are. And then we have Sarah Palin quote, and I found it kind of funny that Sarah Palin has Twitter and I don't even have Twitter. I think I'm a little bit behind the times a little bit. But Sarah Palin, in all her intelligence and glory, suggests that because it's very, very cold in Alaska right now, who would have thought Alaska's cold, that global warming, my gluteus maximus. She does not believe in global warming. Now, the ever so graceful Donald Trump has suggested that because Baltimore has had some cold days in March this year, there's a global warming con. I can't believe that she almost became the vice president of the United States. That's truly fascinating. But this is not uncommon. These are just 4 of the funnier ones that I could find of a very quick Google search. There are a lot of these on the internet. Googling climate change hoax will give you a plethora of information. And what's worse than these quotes is that climate change deniers are now using year-to-year data against climate change. Now, Dr. Bonaventure, Dr. Small, and Dr. Iberguchi, for the last 3 seminar series, were very clear. Climate and weather are 2 different things. That is pretty much the most bang-on point that you can get across from all 3 seminar series, is that they're very different. Climate is not weather. Climate is not year to year. It's the trend. It's a statistically average trend across many years. John Small said 30 years. So stuff like this, you can't really take too much stock on. It's year-to-year differences. They're bound to be year-to-year differences. The ice was so little over here, it had nowhere to go but up for the next little while. And it's probably going to go down again. But once again, we don't know these things. You have to look at trends across multiple years. Now, climate change deniers, although much more adamant in the United States, are still present in Canada. Except in Canada, we don't call them climate change deniers. You call them Joe Oliver and Peter Kent. Now, Peter Kent was the Minister of the Environment. You might know this handsome fellow over here. He, along with King Harper, was the one who's responsible for the downfall of environmental policy in this country. He's also the one that Justin Trudeau directed his comment at, "You piece of blank." Just a little bit of an anecdote there. That is true. And over here, we have the ever-graceful Joe Oliver. Now, up until very recently, Joe Oliver was the Minister of Natural Resources. He's the one who's been quoted a lot by climate change researchers. He's the one who has very polarizing quotes. Today, he'll say something along the lines of, "There's no consensus in the literature according to climate change." And tomorrow, he'll say things like, "Climate change science is on the way down. Most researchers agree that climate change is not a thing." Now, Joe Oliver has now replaced Flaherty as the finance minister, just as an FYI. So based off of what's happening in Canada, I decided to comb through the data. I decided to comb through, comb through is kind of a relative term. I decided to go through as much as the internet as I could and summarize 5 of the biggest arguments that are brought up in Canada and in North America. Because we've already discussed media publications, we've already discussed science publications, we already discussed why media and science are not always going to align. So now let's look at, what are the arguments that the media is using? And I'm going to touch on 5 of these. The first one, not all experts agree. I love this. What is an expert? And it's such a trivial question, but it's true. For example, just because Peter Kent is an environment minister doesn't mean he knows anything about the environment. Now, Dr. Bonaventure touched on this in the first seminar series. Climatologists and meteorologists are 2 different people. They study 2 different things. So meteorologists are not properly trained to gauge climate, and nor are climatologists properly trained to gauge what's going to happen to the weather patterns tomorrow. It's important to understand what people say, expert, what do they actually mean? Who is the expert? If every blogger or Wikipedia reader or politician is an expert, then yeah, fine, maybe climate change is not happening. But thankfully, it's not really the case. So I decided to go directly to the literature. Let's look at peer review articles, because that's the most important thing over here, is peer review. So over here, I've graphed the number of peer review articles from November 2012 to December of 2013. The red tells you the number of scientific peer review articles that suggest climate change is happening and it's anthropogenic. The blue shows a peer review article that says climate change is either not happening or is happening but is not anthropogenic. There's blue there. It's really hard to see, but if you squint your eyes, it's one line that's going. Now it's really hard to see, so I kind of just gave the numbers over there, right? In the last year, we've had 2,259 peer review articles that have mentioned climate change in their abstract. from 9,136 authors. Of that, all but one say yes to anthropogenic climate change. Now, I've said time and time again that you need multiple samples. So let's go ahead, and I found another study that looked for the last 21 years. Sorry, this is 99.9891%, just in case anyone's keeping track of numbers. So let's take a look at what's happening in the last 21 years. So in the last 21 years, there has been a total of 13,000.
Your attention, please. Circulation service will end in 25 minutes. Please break. Thank you.
All right, so I suppose no one has any books out, so let's carry on, I suppose. So almost 14,000 articles were published in the last 21 years that made a mention to climate change in the abstract. Almost all of them said climate change is anthropogenic. That's 99.83% of peer review articles. Now, when polled, so that's peer review articles. When you simply go and you ask climatologists, do you think climate change is happening? 97% of them said, oh yeah, climate change is happening and it's human caused. There is no doubt in their mind. So we have numbers ranging anywhere between 97% and 99.98%. Now, scientists, we rarely agree on anything. We're always polarizing. But when you have 99% of them on one side, that's something to consider. So not all experts agree. Well, that's just wrong. And then I thought, so why is this happening? Where are all these numbers coming from? There's 50%, there's 60%, there's 70%. And I think I landed on the answer with a popular publication poll. So very similar to the methods that we used in the other studies, they used over here, except instead of looking at peer review articles, they looked at media articles. And while looking at media articles, they found that 52% of media publications think that climate change is anthropogenic. That means 48% of them think that either climate change is not happening or it's happening and humans are not the cause. So you can see that the public looks at this and thinks, oh, well, that's the same thing as peer review publications, but it's not. The second argument is humans don't cause warming. Now, this is a brilliant graph that Dr. John Small showed you guys 2 weeks ago. And this is ice core data from Antarctic. And we can go back to 800,000 years ago, all the way to present time. And you can look at temperature, which is in the black. We use temperature proxies, or you can measure carbon dioxide in the red. Now, I like to show this for two reasons. One is you can see the natural variation over spans of hundreds and thousands of years, which I think is really cool. But the second reason why I like to show this is when did humans evolve? When's the first confirmed presence of Homo sapiens? We're looking at between 400,000 and 250,000 years ago. We actually have data of climate before humans were even on Earth, or even before humans were even involved. And that is really important because you can really start to understand natural variation when you start to think about this stuff. And this is, because it's really hard to see what's happening over here, kind of zoomed in. And it's the exact same thing. On the x-axis over here, we have our calendar year, so 0, and what's happening in 2000. And the last data that's showing over here is from 2004, so it's 10 years ago. We have temperature anomalies over here, and the different colors refer to different methods of collecting temperature data. And as you can see, if we look over here, the black is actual measured data. Humans are causing warming. This has been proven to you guys by Dr. John Small with his research. This has been shown to you guys by Dr. Philip Bonaventure, and last week Dr. Ibarguchi showed you about the effects that we are causing. This is human instructed. This is us. Now, the third argument often used is polar vortices and cold weather. Now, all past presenters, once again, have said the exact same thing. Weather and climate, not the same thing. No single weather can either prove or disprove climate change. You have to look at the trends of these over multiple years. And Dr. Ibarguchi mentioned strong differences are the things that actually drive these weather patterns. So very briefly, how does the polar vortex form? What is it and how does it come from and how is climate change going to influence it? Now this is a very quick and dirty way of explaining it. But in essence, the Arctic is warming up far faster than areas of our mid-latitude, right? So what we're showing over here is how warm it's getting. And you can see that it's getting much warmer in our Arctic area than it is in mid-latitude. And in essence, the temperature range between very cold and very warm is what drives a lot of these circumpolar vortex. A lot of these circumpolar air masses are driven by very large differences between the cold and between the warm. Now, as this temperature range goes smaller and smaller and smaller, you start getting a little bit more of a wavy airflow, right? So instead of having a constant airflow around the globe, this starts to get wavy because the temperature range is becoming less and less. And as it becomes more and more wavy, you have very cold Arctic air that comes down to us, and similarly, you have a lot of warm air that kind of goes up to them. So to drive this point home, the day when we were experiencing minus 35 here in Kingston, I think it was minus 35 with windshield, it was like minus 28 without windshield. I checked the weather in Yellowknife, up north, it was 5 degrees Celsius. So weather is changing. Just because we're getting something very cold doesn't mean that other parts of the world are not experiencing warmth. The second last thing is, the fourth argument is data is not accurate. Now, this really started taking off from a publication in 2010. We're going to kind of get to that in a little bit. But in this publication, they looked at the IPCC predictions, because IPCC has been around for many years now. And in 1990, they came up very similar to what we do right now. There's predictions. And according to Climate Depot, which is, Climate Depot is a conservative climate change denying think tank. It is very well financed though. In Fox News, 114 out of 117 estimates were wrong. They were very ardent that climate change predictions forecasted 2 times more warming than actually occurred. Well, I was curious. I'm like, well, if they actually have published works over here, then what's actually going on? So I did a little detective work, not unlike Sherlock Holmes, except I use the internet, whereas apparently he doesn't like using the internet. So I'm a little bit more up to date. And it turns out that they lied. Again, the study that they were citing was this one that was published in Nature Climate Change by Frame and Stone. And this would happen in 2013. Now, in 2010, what ended up happening, these IPCC projections that started in 1990, they projected all the way until 2030. And in 2010, it was the halfway point. So what these researchers did is like, all right, so what happened? We're halfway through. Are these predictions right or wrong? And it turns out they were largely right, except that they underestimated a lot. And why did they underestimate? Because of positive feedbacks. It's what Dr. John Small was talking about. As the world warms, it starts to unleash a lot of other things that also warms. And he talked about the albedo the effect. So these predictions, so these are measured results. This is once again time over here, and this is our temperature anomaly. This is what the predictions were going to be. And as you can see, we're flat right in the middle. Actually, we're a little bit below. So if you take the number of projections that are below these lines and the number of projections that are above these lines, we're a little bit lower than exactly halfway. And that's largely because we underestimated these positive feedbacks. So the data is not accurate. In fact, they are pretty accurate. Actually, more fact, they're actually underestimating a lot of these things. So, but regardless of whether or not each individual year is accurate or not, we have to remember the important thing is to look at trends across multiple studies in multiple years. When scientists disagree, it's always about the mechanisms. It's, do you think the glaciers are going to melt at that rate or this rate? Do you think that fresh water is going to pool over there or over there? Scientists never disagree about, do you think climate change is happening? Do you think it's anthropogenic? That part is absolutely true. In excess of 99% of peer-reviewed publications have shown that. There is no disagreement in the general science. And now the last slide, the last argument. It's, we have our own agenda. I love this picture. The first time I saw it, I was my undergrad, and I absolutely love this. Whereas this person is saying, hey, let's go towards a more sustainable way, and he's suggesting let's go with green jobs, renewable energy, let's clean our water, let's have healthier children, let's stop burning our rainforests, all good things. And this guy's like, well, what if it's a big hoax, and we save the world for nothing? And I just want to go on a little bit of a rant here. A lot of the grad students that are actually at Queen's, a lot of the PhD students, we don't do this for the money. Speaking from experience, there's a healthy amount of recruitment that occurs that tries to pull us away. Reclamation projects, for example, in Alberta, things that are going on the East Coast. These are all things where money is available. Grad students stay in grad school not because of the money. Trust me, it's not because of the money. There's only so much mac and cheese one can eat. They do this because they care. We do this because we want there to be positive change. We don't have our own agenda. So, lastly, I do want to summarize with this one slide. When reading about climate change, understand the science. Look at when and where things are cited. Are these citations coming from peer-reviewed journals? So generally in the media, when you read something online, if it's done right, they will provide a research-based citation. Check that out. Are they saying what the media is saying that they're saying? Ultimately, individual publications may be wrong, but if you look across all the publications, there's thousands of them that say the same thing. That means something. Second thing is, look at the funding. Where's the money coming from? Time and time again, it has been proven that taxpayer research is the best kind of research. There's fewer retractions, there's better science, there's more honesty. Tax-based research is the best research. So let's look at that. Who are the experts? Politicians don't count, by the way. Who are the experts? And polls cannot substitute for science. Polls tell you what the public is thinking. Polls do not tell you what science is saying. Those are two very different things. And with that being said, I thank you for your time, and should anyone have any questions, I'll field them. Thank you.